Hello everyone, I'm very honored today to present to you our paper in KDD 2019. Spatial representation learning aims to automatically identify effective features of geographic entities from unlabeled structural geographical data. A geographic entity could be any spatial unit such as a city or a state. It's also a place where people live, work, or entertain. Some preliminary studies mainly focus on learning representations from homogeneous network or heterogeneous network, but they all fail to capture the intra-region structural information. Some other approaches also regard a region as a graph to reformulate the problem as graph embedding, but they ignore the inter-region or cross-geotype correlations. So our goal here is to preserve both intra-region geographical structures and inter-region spatial correlations, and we want to simultaneously address the above two tasks in a unified unsupervised learning framework. So we proposed a non-supervised collective graph regularized dual adversarial learning framework, which first construct multi-view spatial graphs and then extract variants of region-region correlation graphs from multiple sources, and then eventually develop the framework to learn the embeddings of regions. So here are the two different views of graphs we used in our paper. The left side shows the geographical distance view, which models the geographical distance among different POI categories, and the right side models the human mobility among different POI categories. Here's an illustration of the collective learning component in our framework. G1 to GK represents different views of graphs of regions. They each get projected into lower dimension embeddings first, and then they all get mapped together into one vector space, which is further reduced to the embedding space. And then the decoder decodes them back to the original graphs. So in addition to the collective learning component, we also introduced two adversarial learning components into our entire framework. The bottom one imposes a normal distribution onto our embeddings, and the top one tries to enforce our batched pairwise embedding autocorrelations to match a prior region correlation matrix. We also tries to minimize the reconstruction loss, which tries to preserve the intra-region structural information. And then we evaluate our framework with an application that predicts check-in volume using learned representation vectors. Thank you very much for watching, and welcome to our presentation at KDD 2019. Feel free to let us know if you have any questions. Thank you.